right, guys, are there any questions over any of the assignments so far? Any question over anything we've done so far? All right. I believe this is where we stopped yesterday. We got to this problem. We finished the last one with sine squared, and we're looking at this one here. Now, we are trying to solve this one here for the value of x. What x is going to be so that these two sides are equal. It would be very tempting to try to divide cotangent out of both sides, but if we do that, we remove a solution. Anytime we divide x on all sides, especially when solving, we remove a solution from the overall system, or multiple in this case. But the first thing we can really do is get this equal to 0. So we can subtract 2 cotangent of x from both sides, which is really going to tell us that we have cotangent of x times cotangent, not cotangent, cosine, square root of x minus 2 cotangent of x is equal to 0. So the first main thing we want to do is actually get this equal to 0. And we did the same thing, especially with higher degree polynomial functions. And a lot of the times when we were solving equations in Algebra 2, we got it equal to 0. And the reason we do this, and the reason we kind of get towards this, is if we can use the zero product property. Multiple things multiplied together equals 0. One of them must be 0. And one of the nice things, especially once we get this equal to 0, highlighter, both of these two expressions do have cotangent, yes? Since they have cotangent in common, what we can do is we can factor it out. So we can say that we have cotangent times, well, if I factor cotangent out of cotangent times cosine squared, we're left with cosine squared of x minus, if I factor cotangent out of 2 cotangent of x, we're left with 2 is equal to 0. Now again, we do have two things multiplied together equal 0, yes? So one of them must be 0. So either that cotangent of x is 0, or cosine squared of x minus 2 is equal to 0. So we have one of these two cases here. We can start off with the one on the left, so cotangent of x is equal to 0. We need to find out what value of x is going to make this be 0. Now, unlike sine and cosine are easy to determine when they're 0, mainly because of the unit circle. Because our unit circle gives us those values, especially with 0, 1, 0, 1 half, square root 3 over 2, square root 2 over 2, any of those. But what do we know about cotangent? Cotangent's the same as what? I started writing tangent. It should be cosine of x over sine of x. And this is one way we can think of it using the unit circle. If we're not as comfortable thinking about tangent and cotangent on the unit circle. So cosine of x over sine of x, and we're wanting it to be 0. Well, the only way I can have a fraction be 0 is if the numerator is 0 and the denominator is something other than 0. So we're really trying to see where is cosine going to be 0. And on the unit circle, there are two places that cosine is 0. One of them is at pi over 2. And the other is at 3 pi over 2. For sine, pi over 2 is 1. And at 3 pi over 2, sine is negative 1. But that doesn't matter because at pi over 2, really we're saying that we have 0 over 1, which is still 0, yes? At 3 pi over 2, we're saying that we have 0 over negative 1, which is still 0. Because whenever sine and cosine have a value of 0, we have two spots. But if sine or cosine is 1, we're only going to have 1. Or if it's negative 1, we only have one spot, because it's either 1 or negative 1. Luckily for us, 0 does not have a sign. It can either be positive nor negative. 0 is not positive or negative. It's not odd or even. It's a weird number. And all we can say it's weird because we can't call it odd. I know, bad pun. But we have these here. Now again, we weren't restricted on what our domain is, our value, so we end up having this plus 2 pi n. Now we do have the other case. We have cosine squared of x minus 2 is equal to 0. Well, next thing we can do to solve this is to add 2 to both sides. Which is going to tell us that cosine squared of x is equal to 2. Then what can we do next? We can take the square root of both sides, telling us cosine of x is equal to plus or minus square root of 2. No. Unfortunately, that's not going to be a nice number. Partially because it is the square root of 2, and also partially because the square root of 2 is not one that works out well. Yeah, still doesn't work out well. Because what is the square root of 2? Well, for most of us, we're not used to trying to take the square root of a number without a calculator, yes? If we're approximating, we try to see what perfect square is close to it. Well, the closest perfect square, so we have 4 is normally the first one we think of for perfect squares, but there's one smaller than it. 1, yes? And it's bigger than 1. So if we looked at, say, the square root of 2, we have 1.41421 going on, yes? So I'm going to write this in. So really what we're saying is that cosine of x is equal to plus or minus 1.414 going on, yes? What is the biggest or smallest value cosine can have? 1 or negative 1, yes? Is there any way cosine could be 1.4? No. Those values don't work. And again, this is something we need to pay attention to, because we had it in the last chapter on the test. I threw it in there because if we take the inverse of sine or cosine of a number greater than 1, it doesn't work. It doesn't have a solution. So this here, even though we do get a solution here, that cosine of x is equal to plus or minus the square root of 2, it doesn't work. It doesn't give us a value because that number is too big. So our only real answers are these here. So the plus or minus square root of 2 or cosine inverse of plus or minus square root of 2 are our extraneous solutions. Our actual solutions are x is equal to pi over 2 plus 2 pi n, and x is equal to 3 pi over 2 plus 2 pi n. Are those pi units apart? Pi over 2 and 3 pi over 2? Well, that's straight up and straight down, isn't it? On the unit circle. So we could actually simplify to that there. Because if they are pi units apart, they're on opposite sides. Then we could rewrite those two as using pi n instead of 2 pi r, or 2 pi n. Questions on this here? But again, I would have taken those two answers just fine. I would have taken either version of this, because it is the same thing. Any questions on anything we've done so far? Sine squared of x is equal to sine of x. What can we do first? Is it equal to 0? That's where I always start. Unless something else jumps out at me, I try to get this equal to 0. Okay. So sine of x, sine squared of x minus sine of x is equal to 0. So we got it all on the same side. We got it equal to 0. Now, I know especially with quadratics, one of the ways that y'all got, after y'all got comfortable with using a graphing calculator, one of the ways that y'all jumped to, especially when we started talking about higher degree polynomial functions, is to graph the thing. Because if it graphs and we find the same number of solutions as the degree, we're done. We have all of our solutions. We could try that here. Because I could pull the graphing calculator up and see if it'll let me do it. All right. Try it again. Y equals, I'll have to clear these two out. We could say sine of x squared minus sine of x. Graph. Okay. We do have solutions because we do see two different spots, possibly three different spots where it does hit. Because we see the two close together. Because we have these two. Let's see here. This again. These two here, and this one here. And it looks like that's going to be the repeat, but again, we can look at this and try to calculate it a little bit better. Now, for some of these here, if we want to and zoom Z-trig, this will get it so that it looks a little bit closer to the trigonometric values, so we can see it a little bit easier. So we do see it comes down, crosses, hits, crosses, hits, crosses, hits. So there are some nice values if we look at it in a trig form. Okay, looking back at this here, so we have sine squared of x minus sine of x equals 0. Is there something in common with both of these here? Sine, isn't there? Because, I mean, this is the same if you want to think of it as x squared minus x. They both have, for x squared minus x, they both have x in common. Sine squared minus sine, they both have sine in common. So what we can do is factor out a sine of x from both terms. And if I factor sine out of sine squared, we're left with sine of x. minus. If I factor sine out of sine, I'm left with 1. So we have sine times sine of x minus 1. And again, any two things multiplied together equal 0, one of them must be 0. So either sine of x is 0, or sine of x minus 1 is 0. It'd help if I didn't try to put the minus 1 inside the parentheses. Now sine of x equals 0, we've already pretty much got it there. We just need to see what values of x is going to make sine be 0. Again, 0 is a nice number. It's on the unit circle. Sine, our y value, so x is equal to it at, well, 0 radians, or 0 degrees, which is 0. And the other place is at pi, yes? Those are straight across from each other. So realistically, we could combine these two because, again, they didn't restrict us. So we could write it as 2 pi n. But instead, we could say x is equal to 0 plus pi n, yes? Is 0 really adding anything to this? So it's really just pi n. Now when we look at the other one, sine of x minus 1 equals 0, well here we have to add 1 to both sides, which tells us sine of x is equal to 1. Well, between 0 and 360, there's exactly one value of x that will make sine of x be 1. And that's when x is pi over 2. And then we have plus r2 pi n. And these here are our solutions. Questions on this here? And again, we could try these out and see. So we can grab the graphing calculator and say second calculate value 0. It is indeed 0. We could go second calculate value pi 0. Second calculate value, and our other one was pi divided by 2, 0. And we can check any of these values and make sure that they do work. And for the most part, all the ones we've done so far, the values do work. We don't necessarily need to check them at this point. We will get to some where checking is important. Questions on this so far? Okay. Now this one here is the first one we're dealing with that we don't have to add the 2 pi in. We will use it, we can use it to help us find the rest of the values that do work for it, but we don't need it as part of our final answer. So for this here, we want to find all the solutions of the equation 2 sine squared of x minus sine of x minus 1 equals 0. I mean, we could come over here and say 2 sine of x squared minus sine of x, I think it was -1 for this here. Yep. And I could hit graph. And some of these graphs here do look quite funny. Now, again, they wanted us to restrict the domain, or restrict our angles, our value of x's, between 0 and 2 pi. 0 and 2 pi. Now, if I wanted to calculate value 2 pi, okay, that's right here. That's where the x value is. That doesn't tell us much, because 2 pi does not cross the x-axis. It's not a point on the x-axis, it's not 0, is it? No. But I do know where 0's at. 0 for x is right here, yes? 2 pi is right here. We're restricting all of our solutions between these two spots, yes? How many times does this intersect or cross the x-axis? We have 3 spots here, don't we? And it could be 4, but we do have at least 3. Actually, we have probably 4. And the reason I say that is because, again, this is going back to our algebra and graphs, algebra 2, where we talked about even and odd functions. We have an even multiplicity if it intersects the graph but does not cross it. So on one of the spots, it does look like it hits the graph but doesn't cross, so there might be an even number there. The other two cross, so it's an odd multiplicity, most likely 1, but we could have 3. So at minimum, we have 1, 2, 4 possible solutions for this here. 4 possible values that could work. But the 2 where it touches are going to be the same. So really, we're looking at 3 unique values. And that might not seem neither here nor there, but it gives us an idea of what we're looking at how many values that we could have. So we know when we have enough values, enough solutions to be done. So what we're looking at is this. 2 sine squared of x minus sine of x minus 1 is equal to 0. We can solve this by factoring. And trying to factor this, especially if you're not comfortable with factoring with sine, that's fine. What we could do is use substitution and say u is sine of x. And when we use u substitution, we're really setting u to be a value so that it rewrites the equation, well, not rewrites. It reshapes the equation into something we're used to looking at, something we're used to working with. So our new equation here, we still have 2. This is sine squared. Well, we set u as sine of x, so this is going to be u squared minus u minus 1 is equal to 0. And I think we're a little more comfortable looking or factoring 2u squared minus u minus 1. And if we're going to factor this, I look for greatest common factor first. Well, unfortunately, there's not one. If there was, it would hopefully have made it a little bit easier to work with. But there's not a greatest common factor between these 3 terms. The next thing I do is I write 2 sets of parentheses with 3 spaces. I mainly do this again to give myself enough room in each one of the parentheses to have everything be able to fit nicely. The next thing I look for is signs. Now, when I look at the signs, I always look at the third term in this quadratic, which is -1. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. Since it's -1, we have a positive and a negative. And lastly, we look at the factors of the first and third term. So if we looked at the factors of 2u squared, well, the only factors of u squared are u and u. That's the only way that we'll work with this and multiply together to give us u squared. The only factors of 2 are, well, 2 and 1. And again, I'm just throwing these in because our last main check, especially with factoring, is to check to make sure we got it right. So we have all the factors of 2u squared. That will work. Well, the only factors of 1 are 1 and 1. At this point, we can check it. 2u times negative 1 is negative 2u. 1 times u is going to be plus u, which gives us a negative u. That is indeed the middle term we wanted, so these are our factors. Questions on this here so far? Now again, we're wanting to solve, and we now have two things multiplied together to equal 0, yes? So one of these two must be 0. So we're saying that 2u plus 1 is equal to 0, or that u minus 1 is equal to 0. Now I'm going to pause at this point and say, you're probably wondering when we're going to plug sign back in. We could do it now. There's nothing wrong with that. We could finish solving for u and then plug it back in. I could have plugged it back in before we set them equal to 0. We just need to remember before we're done to put them back in. So at this point here, we could say that this is 2 sine of x plus 1 is equal to 0. And this here is sine of x minus 1 is equal to 0. And really at this point here, we just need to get sine of x by itself. Then we would, so we would minus 1 first, then divide by 2, telling us that sine of x is equal to negative 1/2. On the other one, we can add 1 to both sides, telling us sine of x is equal to 1. Any questions on any of this so far? Now, at this point here, especially for geometry, or if you covered this in Algebra 2, because I know we didn't, you would use sine inverse, or arc sine, for both of these here and go from there. And that would be the perfectly reasonable step. And then we'd have to go from there to find the other angles. Now looking at these here, is negative 1/2 and 1 on the unit circle? Are those two on the unit circle for values of sine? And if they are, I go straight to the unit circle instead of using arc sine or sine inverse. Because arc sine and sine inverse will only give us values between negative pi over 2 and pi over 2. Those are the only values it'll give us. Well, negative pi over 2 to 0 isn't within our range because we still need it between 0 and 2 pi. So we would have to make that positive and work from there. Also, again, we're between 0 and 2 pi. It doesn't give us anything from pi over 2 to 3 pi over 2, the other half of the unit circle. So if it's on the unit circle, let's use the unit circle. That's why we haven't used sine inverse or cosine inverse or tangent inverse. Because if it's on the unit circle, we're going to use that. And if we look at this here for negative 1/2, again, I'll look at the unit circle, and if we go around looking at the y values, the first spot that we have is 7 pi over 6. And if we keep going, negative 1/2, we get to 11 pi over 6. And that's it, because at that point we've made it all the way around the unit circle, all the way from 0 to 2 pi. So those are our two values, the only two spots where sine of x is negative 1/2. Now the other case is when sine of x is 1. And there's only one spot for that there, and that's pi over 2. Any questions on this here? And again, we could pull the calculator up and check this here, so I can go second trace, if it'll let me. Second trace, value, pi divided by 2. We do get 0 at that value, it doesn't cross, but that's fine. Then our next one is at 7 pi divided by 6. We do get 0. And our last one is at 11 pi divided by 6. And we do get 0. So we do have these three values, and that's it. Now I'm definitely going to look into seeing why the even multiplicity and odd multiplicity didn't work here. I have a feeling it's doing more with the fact that this isn't considered a polynomial function in the truest sense. But I will look, because I find that interesting. And I'm weird that way. That's fine. There's a reason I do this. But we did find our three values. Questions on this here? And we will end it there. And we will pick this up tomorrow. It might take more than one more day to do this.